Hey, welcome back to our second live stream of the night. My name is Scott Ford. I'm a teacher here in Humble ISD, that's a little northeast of Houston area, as well as an adjunct teacher for Lone Star Community College. And I am on spring break right now. Um, One day I'll figure out how to take vacation. So spent today doing curriculum development and spending our evenings doing live streams for those of you looking to learn a little bit more about the CompTIA A plus certification, as well as the CompTIA ITF plus certification. I do those live streams this week from on Tuesday and Thursday, but Monday and Wednesday are the A plus ones. Depending on the feedback I get from this might be an actual regular occurrence where I might be doing some live streams from now until the end of this semester for those of you looking to get certified. If you joined us for our last one, you know, of course, that while our program isn't sponsored by Bones Coffee, it is sure powered by Bones Coffee. And so during the first live feed, you saw my coffee cup. Well, now I've got a much larger coffee cup because it's already 7:30 at night and this thing isn't scheduled to end until 9 o'clock in the evening. So hopefully you got your caffeine beverage of choice out there. Okay, real quick before we jump into the actual other material, I did want to share our Discord QR symbol. For those of you who are in Discord who might not be in my classroom, you are more than welcome to join us. I've got a bunch of my high school and college students in there. So you can join, you can ask questions. I also have a website. Let me pull that up for you. Mr. Ford's class, extend the session, mrfordsclass.moodlecloud.com. This is a site that I pay for out of my own pocket. And if you are out there, I am more than happy to let you into our course. No charge for right now. Maybe down the road one day I may charge folks for this. But for right now, it's completely free. And you're more than welcome to join us. I have the Computer Maintenance 1 course right here with these units that we cover. And then I am building out Unit 2 right here to help you study. Now, for those of you who don't know who I am too much, I've been doing this for 20 plus years. I actually had the highest pass rate in the state of Texas for students working on their A+ certification. I actually worked for Mike Myers and his folks for about a year. I was his director of training. So I would develop the training that we'd go out to elsewhere and do trainings. I also did cybersecurity and cyber training for the FBI Cyber Division. I've also done training for CompTIA. They've actually paid me, this is pre-COVID, to go out and do trainings. I did about 2.5 month training in San Antonio and about a 2-month training in San Diego, California, which is just gorgeous, for the Wounded Warrior Project. So a lot of experience doing this. I'm redeveloping the entire curriculum. So again, you're more than welcome to join us. You can learn about the certification as well as being my guinea pigs while I am, getting the stuff down a little bit more. Okay, so without any further ado, let's actually jump into what we're here for tonight, which is working with storage. Now, on our last live stream, we looked at kind of the mechanics of storage devices. We looked at what a storage device was. We took a look at the form factors, how they connected, the connection standards like SATA, PATA, and all that fun stuff. In this presentation, we're going to look at actually how to implement these. So let's say that you watched the last live stream and you get all excited and you're like, okay, I'm going to go to Micro Center or Newegg or Best Buy or whoever, and I'm going to go buy a new hard drive. I'm going to buy a 5 terabyte, 10 terabyte hard drive. And you take it home, you plug it into your computer, and nothing happens. Well, it's not that the drive is broken. It's because you don't know how to, or you may not know how to actually work with them. And so that's the focus of this live stream. All right. Now I will also give this one warning that the PowerPoint will crash at least once during this live stream, maybe twice if we're lucky enough, but let's go and hope fingers are crossed. All right. So our objectives for this live stream are describe the concepts of partitioning and formatting, explain the purpose of file systems, describe the most used file systems and their major features, create partitions on a storage device, format a storage device, describe and use best practices for maintaining and care of storage devices, and troubleshoot hard drives. I can't look at Discord right now because I'm in the middle of a live stream. Hopefully, I believe Leaf is in here. He's one of our admins for our Discord channel. He's also my oldest son, who's also working on his A+ certification. So everybody's working. My wife's working on the A+ certification. My oldest son's working on the A+ certification. So surrounded by people who want to learn, which is amazing. All right, so how to use a hard drive. So far, like I've said, part one, we looked at the physical aspects of a hard drive. This is how we actually make them work. And we have to introduce the concepts here. We have to introduce how we get hard drives to work. And in order for a hard drive to actually be functioning for our needs, we have to have low-level formatting, partitioning, and then high-level formatting. So before we can use a hard drive, these three things must occur. It must be low-level formatted, it must be partitioned, and it must have a high-level formatting done. So looking at low-level formatting first. Now, before the drive even leaves the manufacturer, they are going to run a low-level format on it. What they're doing is that no hard drive is perfectly made. There are some flaws in a hard drive. There are sectors on a hard drive that can't be read to or written to. And so by doing a low-level format, they are checking the hard drive for these errors and these things. And so they'll still release it, by the way. But this is usually done at the factory. Now, we do say text can perform a low-level format in the field, but it's not the same thing. So this is where our verbiage gets a little weird. There could be exam questions on the test that expect you to know that in order to wipe a drive clean, to protect the information, to wipe it completely clean, you need to do a low-level format. But it's not really a low-level format that you find in the manufacturer, okay? A low-level format, what they're talking about, is kind of like a DBAN. DBAN is, actually, let me pull that up for you so you guys can see it, as long as because I'm going to be talking about DBAN several times here. So while I am here, let me put that over there. So this is DBAN. That's a very powerful, very free tool that you can use to wipe your drive clean, okay? And this is what CompTIA would consider a low-level format. It goes over the drive multiple times, it wipes it clean, so information cannot be restored off that drive, okay? So that's what they're talking about when CompTIA expects you to know about a low-level format in the field, okay? It erases data on the drive. By the way, as an FYI, if you are in my class, you have access to practice quizzes. If you are not in my class, again, get into Discord. You can get in touch with me. I'll put you into the online class. You have access to practice quizzes there as well. Not a bad deal. I mean, I'm doing it for free right now. So, you know, can't get better than that. All right, so exam tip. So running a low-level format will, quote unquote, erase the drive data on a drive. If someone wants to donate a computer, for example, and you want to leave the hard drive intact, then you want to run a low-level format before you give it away. So one of the things that we're going to talk about now, as far as the low-level format, the partitioning, and the formatting, is let's talk about building a house or a building of any type, right? Let's think about a house for a second. Low-level formatting is like putting up the outside walls, the windows, and the exterior door. What we're doing is we are creating the framework of what will be the house, okay? We got the concrete slab. We got the kind of the outside walls put up, okay? The outside windows put up, the outside door put up. But it's still not really a house. It's really not a home yet. You can't live in it. But what we're doing is we're defining what will be the home, okay? So this is our low-level formatting. Then we have to partition the drive. With partitioning, the shell of the house is already built. Now what we're doing is we're creating rooms that the house is going to have. So we can create where the bedroom will be. We'll section off where the bedroom is. We'll section off where the bathroom's going to be. We'll section off where the living room's going to be. We'll section off where the kitchen's going to be. So, for example, if you play Minecraft, one of the first things you do in Minecraft is you have to set up a shelter for the night, right? Because the zombies, do I have a zombie sound effect yet? I do not have a zombie sound effect. I will need to get a zombie sound effect. The zombies are going to come out at night, right? So one of the first things you do in Minecraft is you build yourself a shelter, right? You got to build just basically 4 walls and a door. But that's just your first night. That's your low-level formatting, okay? Then, once you survive your first night in Minecraft, you're going to want to expand it out a little bit, right? You're going to put up an area where you might have your crafting area, or your kitchen area, or your sleeping area, or your storage area. And so you might start partitioning off these areas. You might start putting up blocks and walls to where these rooms are going to be. And so that's what we're doing with partitioning. We are setting up areas that we can use later on. So partitioning in the world of computers, in the world of hard drives, we will create electronically, we'll create these rooms, we'll create these spaces on a hard drive. And a hard drive must have at least one partition, okay? And we have different types of partitions that have been supported by Windows throughout the years. We have what we call the master boot record, or the MBR. And the master boot record supported something called a primary partition and an extended partition. We have dynamic storage. We have globally unique identifier, GUID partition tables, okay, GPTs. We also have some other things that we're going to look at. So let's start to break down our partitions first. First, we have the old school way. This is the old way to do this. We have the master boot record, or the MBR. You might also hear this called the basic disk. And the first sector contains the master boot record. The master boot record tells us, hey, where to find the operating system. This also contains the partitioning table, details about how many and the size of the partitions on the disk itself. The master boot record partition table supports 2 other types of partitions. It supports a primary partition and an extended partition. So the primary partition, the key word when we're taking a look at primary is bootable. This is where your operating system lives to be booted to start up. And you can have up to 4 primary partitions. That's it. Or you can have 3 primary partitions with something called an extended partition. We'll look at that in just a second. By the way, don't worry if some of these words are going over your head. We're going to go into these in more detail. We're going to break them down. But right now, we're just introducing the words and the concepts. But believe me, by the time we're done with this live stream, you'll have this stuff down, okay? You'll get it. So don't freak out. Don't panic if you're going, I don't. Okay, we'll get you there. Just relax, okay? Just relax. Drink some coffee. Feel your heart racing. Okay, now we're relaxed. Okay, moving on. So, one primary partition can be active at a time. The primary partition that's active is the one we boot to. And we typically assign this active primary partition the letter C. And I said this in the previous live stream. I've said it before. The reason why it's C is because in the early days of computing, there were no hard drives. All there was floppy drives. And so we had drive A and B. That was for floppy drives, and that was what we used. Okay? C drive, the hard drive, didn't come out until later. And it's been that way ever since. So then we also have an extended partition. When we think of an extended partition, I want you to think of storage. Okay? I want you to think of back to our Minecraft analogy for a minute. So you might have, as you develop, right, as you develop your character, as you start to accumulate more stuff, you might need an entire area for storage, right? You might need an entire area to store wood and iron and coal and diamonds and wool and what have you. And you might not want them in your main area. You might want to have just this separate area that is just for storage. Okay, just chests and chests and chests of storage. Well, that's what an extended partition does. It is not bootable, okay, and it's typically used for storage of data and stuff. So this can have only one extended partition. But, you divide that one extended partition into a whole bunch of smaller logical drives, or one big logical drive. It's your choice. But the fact here is, or the takeaway here is, one extended partition that you can then divide into one logical drive or a whole bunch of logical drives. Now, by itself, an extended partition cannot store data. You need to create at least one logical drive to store the information. The logical partition is created within the extended partition. Okay? So within the extended partitions, the logical partition holds the information. And there are no limits to how many of these you can make. Now, you can't set these to active. These cannot be booted to. They cannot be where you have your operating system at to boot to that. Okay? And like I said, it's normally used just to store data. So keeping track of how this all is going to come together. We have partitioning. Within partitioning, we have the master boot record. In the master boot record, we have our primary partitions and we have our extended partitions. Underneath our extended partitions, we can have one or a whole bunch of different logical partitions. Now, pop quiz for you. Pop quiz for you. How many total primary partitions can you have in the computer? How many total primary partitions can you have? Four, or three with a extended partition. Okay, so remember that. Moving on. That was a very clever way, by the way, to take a coffee break. Yeah. All right, moving on. So it didn't take long for us to figure out that the master boot record stuff had some limitations, right? It was created back when the dinosaurs roamed the earth, and we needed something new as technology evolved. And so along came something called dynamic disks. And dynamic disks were introduced with Windows 2000, the server and workstation. Now you find them on all of our Windows computers. They are now part of our computers today, okay? Partitions have now had a name change. We no longer really call them partitions, we call them volumes. And there is no limitation on the number of volumes that we can have. So the primary and extended partitions are gone, okay, in the dynamic world. We call them volumes. And dynamic disk and the volumes introduce additional capabilities. So for example, we can have spanned volumes, we can have RAID, and we can have extended volumes. So let's actually, I'm going to pop out of this for just a second. Let me go here and we're going to try something. And I am fairly sure that I'll be crashing PowerPoint. We'll see how this turns out. So what I'm going to do right now is, this is a program called VirtualBox. It helps if I show you what I'm talking about, right? This is a program called VirtualBox. Okay. Exit out of the show. There we go. I meant to actually do that this time. Yay, me. All right. So what we're looking at here is a program called VirtualBox. It is a free virtualization program. And I love it. It is phenomenal. It's got a lot of features. It's great as a training aid. It's also fantastic as a teacher because I can have students use this. And again, it is free. So I'm taking a look at my my VirtualBox here, okay? Go to details. So there we go. And I'm going to start VirtualBox up. And I'm going to tell you right now, I'm going to have to go out of this in a second to add what I need to add. So let me click Start. And what we're going to see is a virtual machine, a hypervisor. Remember that word, hypervisor, loading Windows 10 Pro. I believe I have Pro installed. By the way, remember, Windows 10 Pro is not short for professional. Windows 10 Pro is Windows 10 Pro. So we're going to let it boot up. Hopefully this works. We're going to find out together in real time, or you'll be watching it on playback. Come on. I need like a jingle. I need to get the jingle for Jeopardy. Okay, so what we see right here is Windows 10. Okay, Windows 10 Pro. And let me open up my File Explorer. Okay, File Explorer being open. There we go. And when I look in my PC, in this PC, I just see the hard drive. That's all I see there. Okay. I am going to need to add some additional hard drives to do what I'm about to show you. So I'm going to close out of that, and I'm going to close out of this. I'm going to just do a shutdown. Let me do a shutdown here. Now, what I'm about to do in VirtualBox is not on the exam. This is not testable at all. But I'm going to show you how I set this up so that I can add additional drives to this virtual environment, to this virtual machine. So back over here, I'm going to go and click Add. Not that what I want. I'm going to go to Settings. That's what I'm looking for, Settings. And I'm going to click on Storage, and I want to add some additional drives. So I'm going to add I'm going to add a couple of hard drives. Let me pull this back over here. It keeps going back to my other monitor, but I want you to see what I'm doing here. All right, so I want to actually create a hard drive. Okay, I'm going to call this drive. Also, I spell it right. Drive 1. And we'll leave it at 50 gigs, okay? I'm going to click Finish. And I'm going to create another drive. I'm up here and Create. I'm going to create another drive. I'm going to call this, let's see, Drive 2. Drive 2, and we'll leave it at 50 gigs, okay? So I've attached that drive. I need to attach the other drive. Let me pull this back over. It keeps popping up out of my main one. All right. So what we're seeing in the back right now is I have attached 2 separate hard drives to our virtual system, right? I've attached 2 drives to my appliance, to Windows 10. I'm going to click OK. And then I'm going to start Windows 10 over again. So let me click Start, and we can see right here, right? SATA. If you were paying attention in the last live stream, you know what SATA is, right? SATA serial attached, right? Serial ATA, serial hard drive. So we have these hard drives attached, okay? So that's where the SATA came from. If you don't know what I'm talking about SATA, go back and watch the other live stream, okay? So we have this connected. Let me start up our Windows 10 again. While that's doing that, of course, I'm going to be sneaking some coffee. For those wondering at home, I'm drinking Bones Coffee, Army of Darkness. Just so you know you're not frozen here, I will make little sound effects for you so I can keep talking. All right, so I've attached 2 additional drives. So let's go and take a look at File Explorer. And go to this PC. Now remember, I just said I attached 2 additional hard drives. I'm about to click on this PC. Actually, I just did. You couldn't see it. Let me ask you this question. Are the hard drives that I just attached, are they going to show up in this PC? When I open up File Explorer and look for those hard drives, am I going to find them? Maybe, maybe not. What do you think? And more importantly, why do you think that way? Well, let's find out together. So I have this open, and whoa, the hard drives aren't there. They're missing. They are completely gone, right? They're not showing up. But what I'm going to do is I'm going to go into something much more powerful, and I'm going to go down here to the Start button in Windows 10. I'm going to right click on it, and I'm going to go to Disk Management. Now, if you've never done this before, let me pause and go over this again. All I did was right click on my Start button, and look how many powerful options there are. That's a lot of admin tools right here hiding behind a right click. So I'm going to go to Disk Management, click on that. And what's going on there? What is this? This is initialization. Huh? The first time you attach a hard drive to your computer, the very first time you do it, it's going to want to initialize it. It's going to say, hey, welcome in. We're going to be working with you now. Okay, so it's going to initialize them. Once I initialize them, I'm not going to see it again. So I'm glad this popped up so you can see it. This is normal. This is expected. So initializing the disk. I am going to leave it set for this, the master boot record. Okay. And I'm going to click OK. Now, right here, we see that we now have disk 1 and disk 2. They have been initialized. So let me ask you this question. Will they show up now when I click on this PC? Well, let's find out. No, they're not there. Because if you remember, at the very beginning of this, I said we had to do 3 things to make a hard drive functioning, right? We had to do 3 things so we could use a hard drive. We had to low-level format, which has been done. We have to partition it, and we have to format it. So those are the 3 things that have to be done to a hard drive before we can use them. So we haven't done any of that. All we've done was attach them and initialize them. So the computer's not ready to use them. We're in the admin tools. That's where we can access all this cool stuff. So back over here, I now am going to, as you see, it's a basic disk. I'm going to right click on this, and I can convert it to a dynamic disk. So let me click this convert. And it's going to say, hey, wait a minute. As long as you're doing a dynamic disk conversion, you have these other drives that aren't converted yet. Do you want to convert these other drives to dynamic disks? Well, I'm going to say no for right now. I'm just going to do disk 1, and I'm going to click OK. And now it's dynamic. Okay? So it's that easy. Converting a disk to dynamic is a one-way, non-destructive process. Okay, let me pull up our thing again. So converting to dynamic disk, and we're going to hop back into our VirtualBox in a minute. Okay, so converting to a dynamic disk is considered a one-way, non-destructive process, meaning theoretically, if you already save stuff to it, it's not erased when you do the conversion. Now, saying that, it is good practice. It's a good idea to always back up your stuff. In fact, you should be backing up anyways, but I personally, even though it's non-destructive, still recommend backing up your data before you make the conversion. Better to do something that you really didn't need to do in case something bad happens versus going, oh man, I should have done this to begin with. Remember, data is king. You don't want to lose it. So back up your stuff before you do the conversion. Okay. And so I showed you how to get to disk management. So we're good there. Dynamic disk has some great features, right? We can also do RAID. We have these other things that we can do. What this is actually, some of this is actually hiding RAID. Some of it isn't RAID. So we can create a simple volume. Let me pull up our virtual machine again. So I can create a simple volume, right? I can go here and create a simple volume. I can also create other types of volumes. So I can create a simple volume. A simple volume is nothing more than a regular drive. So let me click on simple volume so you can see it in action, simple volume. A wizard is going to pop up to walk us through the process, which is very helpful. So let me click next. I'm going to take the full size of the drive. Let me click next. And I'm going to give it a drive letter. Let me give it, we'll call it S for simple. Let me click next. This is formatting. We're not worried about formatting right now. Just suffice it to say, doing a quick format so we don't kill a bunch of time. Let me click next. Accept the things that are there. Click finish. And try that again. Let me click finish here. Uh-oh. Come on. I think I just froze. I think I just froze. I think I just broke my virtual box. I think I got too many things running. Anyways, what'll happen when you click finish is it'll make a simple volume. Okay. I'm going to close out of this. I can't believe it just froze. I'm used to the PowerPoint. Honestly, I'm running on this on a bad computer. This is a pretty decent computer. But I'm going to close out of that. Power off the machine. I'm going to see if I can launch it again. To show you all what we're doing here. This is the fun of doing a live feed. Also teaching in person, right? If this was recorded, I could edit stuff out and all this other stuff. But you're getting this live. Things happen. It's part of doing technology training. When I first started doing this would absolutely mortify me, but you know what? It is what it is. I'm rebooting the virtual machine. So just hang with us, drink your coffee, chill, relax. Looks like we're making progress. All right, let me go back into disk management here. There's our disk management. There's our drives. All right. Let's try this again. We're going to do we're actually no, it didn't make it. We're going to do simple volume. So I'm right clicking on it, simple volume. We're going to click next. We're going to take the full. We'll leave it as is. I'm not messing with it this time. We're leaving all this alone, making sure it's a quick format. Click next, click finished. And will it work this time? Fingers crossed. There we go. Yay, it worked. All right, let's see what happened here. Now we have a new volume. If I go into File Explorer down here, am I going to see a new drive attached? Well, what did I say was required? Low-level formatting, partitioning, formatting. We've done all three things, so we should see a new drive. And looky, right there is the new drive. There's our new volume, okay? So that is creating a simple volume. It's just a simple drive. That's all it is. Then we can create a spanned volume. A spanned volume is when we use more than one drive to kind of extend out how far we're kind of combining the drives into one drive as far as Windows sees. So the best analogy I can give you for this is imagine two tables, and you want to make a big buffet table. You take the two tables, you put the tables together, and then you put a tablecloth over it. Everybody sees one table, but it's actually two tables that you can now put stuff on there for the buffet table, okay? So spanned volume is like making a buffet table, all right? So here we go. Let me pull up our drive again. I am going to delete the volume, and we are going to create a spanned volume together if you have it running. So I'm going to click span volume. I'm going to click next. It's going to say, hey, you need at least 2 or more drives here. So I'm going to attach my second drive. I'm going to click next. I'm going to leave everything alone. I've already learned that mistake. I'm going to click next. We're going to leave all this alone. I do want to do a quick format, however, so we can speed things up. And then I'm going to click next. And then I'm going to click finish. And then I'm going to cross my fingers. Finish. Now, wait, what happened? Did I just get a message? What did I do wrong? Well, what it did was it said, hey, look, this feature, this thing that you're trying to do works with dynamic disks. And you don't have dynamic disks. You're in basic disks. You're still doing the MBR stuff. You are in basic disks. Do you want us to convert this to a dynamic disk first, so then we can do the rest of what we need to do? When I click yes, I want you to pay close attention, right here. What you're going to see first is this being converted to dynamic first, and then the formatting, okay? So watch here from basic and see what happens. I'm going to click yes, dynamic, it made the conversion. It's now formatting, it's now spanning, and there we go. We have a span volume. Windows recognizes there's a drive. Let me click on File Explorer. I'm going to go to this PC, and if you remember when I set this up, I set up two 50 gig drives, okay? Now, what we have is two drives that are spanned together, each 50 gigs-ish, and Windows just sees one drive. That's all it sees. But we know on the back end, right, these are actually two drives attached. I can, if I want, go in there and shrink the volume. So let's say that I don't want the full thing to be spanned. I can decrease the amount of space that's on there. Let me do, I don't know, we'll do just, I'm pulling numbers randomly. Let me click shrink and look what happened. The span volume still covers two drives, but I also have space on that other drive that's unallocated, okay, that I can still use for something else, okay? So that's a spanned drive. Then we have striped drives. This is the same, if you remember from when we talked about RAID in the previous live lecture. We talked about the fact that you can do software RAID. Well, now we're going to be doing software RAID. We're going to be using our Windows to create RAID volumes in software. Now remember again from the previous live stream, hardware RAIDs are much more robust, more powerful, because when we're doing a software RAID, Windows still knows that it's not actually one disk, right? From the warm fuzzy view of File Explorer, it looks like one, but on the back end, it still knows there's more than one, which means the software still has to manage it. When dealing with hardware RAID, that's handled outside the operating system, doesn't even know it exists, okay? So, striped volumes is the same as RAID 0. Okay, it's going to take the data and split it between the drives. It's horrible for fault tolerance. Unless you have a very specific reason to do this or spanned, I don't recommend it at all. All right, so looking back at our drives, I'm going to delete these and start over again. So let me delete them. Okay, we're back to square one. So right now, if I go into my File Explorer, the drives are gone, okay? Now I'm going to create this striped volume. So I'm going to click on that. I'm going to click next. I have to have at least two drives to do this in. I'm going to add that second drive. We're going to leave it as is. I'm going to click next. I'm going to leave everything the same. Next. I'm going to do a quick format. I'm going to click next. I'm going to get the confirmation screen. Now, if you're paying attention when I did the previous one, let me pull this over so you can see it. Look at what I'm seeing. Can I do this with these types of disks? I've got two basic disks. Can I do this with basic disks? The answer is no. They need to be dynamic disks. So once again, I'm going to get that pop-up that says, hey, do you want me to convert these for you first? So, and of course, I'm going to say yes. Let me click finish. We get the message. It says, hey, let's convert. I'm going to click yes. Again, watch, because it's going to go from basic to dynamic here. Okay, dynamic and dynamic. We'll let it format while I sneak some coffee. Oh, I heard it's done. Let me go into my File Explorer, this PC, and look what I have. I've got one volume at around 100 gigs, which is the two hard drives put together. Okay. So now we have mirrored. Mirrored is the same as RAID 1, right? It's mirroring the volume. So we're going to go in and we're going to do the same thing. Let me delete the drives again. Okay, delete the volume. Yep. And now I'm going to do a mirrored volume. Click next, add another drive, click add, click next, leave everything as is, do a quick format so we're not waiting forever, click next, click finish. And yes, I need to convert them to dynamic first. Dynamic, and here we go. Boom, done. So we got two different drives. They are mirrored. They are showing in this PC. And notice on the RAID 0, I had almost 100 gigs of space. With RAID 1, it's down to 50 because it's making an exact copy of the OneDrive. Okay. All right, let me delete this. Boom, boom, boom. And we'll minimize. So I'm hoping this is starting to make sense to you all. Okay. If you want to try this on your own, it's very easy to do. This is very easy to do. You just download a copy of VirtualBox. It's a free download. Search Google, search VirtualBox. You can find it. It's from Oracle. You install it. It's a very easy install. And then you want to go find Windows 10. You can download it directly from Microsoft and install it. And you can use it and play around with it. And I would recommend doing that versus actually doing it on your computer. So if you have a laptop or desktop at home and you're trying to follow along, do not do this on your actual computer. You want to do it on the virtual machine so you don't mess anything up. Just avoid angry phone calls now. Okay. All right. Then we have RAID 5. RAID 5 is a software implementation of RAID 5, but it's only found on specific Windows versions. Okay. So I've got Windows 10 Pro and it's not found on that one. Okay. It's going to be found on some of the more powerful versions of Windows, not on your Pro and definitely not on Home. All right. So kind of summing up here what we've looked at. Under partitions, you have the master boot record, right? You've got the primary partitions, you got extended partitions, you got logical partitions, you have dynamic drives, you have simple, span, stripe, mirrored, and RAID. And you know, while I'm in here, let me actually show you the drives. Let me go. Nah, it's not going to play nice. Let me just kind of skip over that, but you get the idea, right? You get the primary partitions, extended partitions, all this other stuff. All right. So then you got the GPT. All modern personal computer operating systems support GPT, supports lots and lots and lots of partitions, and it supports massive size storage devices. This thing's in the zettabytes, right? And we arrange by logical block addressing. You can boot to the drive if the motherboard supports UEFI, which pretty much all modern computers have UEFI, okay? And before we leave the world of partitioning, be aware that there are also two partitions that we don't normally set up but still exist out there. And that is our hidden partition. Our hidden partition usually stores the backup part of Windows and our system files, while a swap partition, only on Linux and Unix systems, the entire partition that works like a page file in Windows. It acts like RAM, okay? So there you go. And I will say something about hidden partitions. When we first had Windows, when we first had computers, you would have your backup disk. You buy a computer and you would have all these floppy drives or CDs with the operating system on them. And if you ever had to reformat, you would put them all in, you reformat the whole computer. And then we went through a transition where you had an option when you first got your computer to make a backup CD of a restored disk, or you didn't even have that. And I'm telling you, I used to work at the tech bench when this transition was happening, and it was very frustrating because if a customer's computer needed to be reformatted, they needed to bring the disk with them. And if they didn't have the disk, they would have to call the manufacturer. Sony was horrible at this, if I remember correctly from back in the day, where if somebody brought a Sony computer in, we couldn't work on it. We couldn't reformat it until they called Sony to get the restore disks. Well, times evolved, and now you don't get the discs anymore. But usually on your computer, there is a restore area. There is a hidden partition where you can restore back to. And in fact, the Windows troubleshooting unit that I'm making right now, you'll learn about how to access this and all this other stuff. But just know that the hidden partition is there as you need to restore everything, all that good stuff. Okay. Okay. We've covered a lot so far, right? We looked at low-level formatting. We looked at partitioning. Now we're looking at formatting. You kind of saw some formatting before. We kind of skimmed over it. Now we're going to dive a little bit more into formatting. So, formatting. In the low-level format, we put the walls up, right? We put the walls up of the building. We put the windows in. We put the doors in. Partitioning, we actually set aside the rooms. We set aside the bathroom, the kitchen, the living room, all that stuff. Now, with formatting, we're actually making these rooms habitable. We are putting furniture in. We are putting wall decorations in. We're putting paint on the walls. We're putting lights in. So formatting allows us now to use that room. Okay, so that's what formatting does. It's taking the space that's been set aside and making it usable, which is also when you saw it show up in my computer. So formatting takes the partitions and changes them to something that can be used. Formatting will create something called a file system as well as a root directory. And we have different types of formatting. You might have seen me use, I was using quick format. So there are different types of formats that we can have. And those are full, quick, and low level. A full format is going to scan the entire drive. It's going through the entire hard drive to make it so it can be usable. As you can imagine, because it's going through the entire hard drive, a full format takes more time, which is why I went with the other one, which is the quick format. A full format, again, checks the whole drive. This is what you should do the very first time you put the hard drive in. If this is a brand new hard drive, you should do a full format because it's also checking for errors so it doesn't write to bad places. Okay. Also good if you don't trust the drive itself. But if you know it's a known good drive, you used it before, and you're just wiping stuff off, you don't need to do a full format. But full format checks the entire drive, and it can take time. During the formatting process, it does make the file system and root directory. The quick format also creates the file system and all this other stuff, but it doesn't go through the entire drive. What it basically does is imagine a book, okay? And the book has all the pages that have stuff on there. And it's not going to go through all the pages. Instead, what a quick format does is it goes to the table of contents and wipes it and makes a new table of contents. It doesn't look at the rest of the book. The rest of the book could be missing pages. A quick format only looks at the table of contents, okay? But it's a lot faster, which is what I use to demo because otherwise we'd be here a while. And then low level format, like we've already talked about, it's usually done at the manufacturer, but for CompTIA's purposes, this can also be done in the field where you're wiping the drive clean of information, okay? All right, and also here's something to be aware of. If a full format takes you longer than expected, then it could be that your drive is going bad. So if a full format's taking a lot longer than you would think it would be, you might have a bad drive. You might want to scan it for errors. All right, then we have file systems. File systems are how the operating system manages files and folders. It's how it organizes the data. This goes here, this goes here, this is how we access this is how we access that. Okay, so file systems are how we organize our information. And there have been a lot of file systems developed over the years. There are a few we obviously need to be aware of. So here are the big ones that we should know. Under Windows, we have NTFS, exFAT, FAT32, and FAT16. Under Mac OS, we have APFS and HFS+. And then in Linux, we have extension 4, extension 3, and extension 2. So beginning with FAT. FAT stands for File Allocation Table. FAT16 is old. It is back in the 70s, okay? So back in the disco groovy days, where your parents or your grandparents, went to the disco and danced to the Bee Gees, okay? So This was really old. It was for a 16-bit system, and it could only support volumes up to 2 gigabytes when it came out. That is insanely small to compare today's standards. Your phones have more storage space than FAT16 could handle. Now, they did up it to 4 gigabytes, but again, very, very small. FAT32 came out with the release of Windows 95 on the service release number 2. And the 32 stands for 32-bit file systems. And this could support up to 2 terabytes. Now, one thing you need to know about FAT32, it is the universal file system. Mac OS, Linux, Windows, pretty much every operating system out there can read, pull information from, and write, save information to a FAT32 formatted storage device. Okay, so FAT32 is a universal file system. Remember that, that is important. Okay. Well, as removable drives became much more popular, okay, as they became definitely something that were being used more and more, and I don't have something I was going to show you guys, we found we needed more technology. And so Microsoft in 2006 created something called exFAT, and it was designed to support USB flash drives and SD cards. Microsoft did release the specifications in 2019, although they still own the patents in the technology. But if you're going to format a thumb drive, chances are you're probably going to be using exFAT. FAT32 only works on, FAT32 only works on drives up to 2 terabytes or smaller. We needed something, and this was especially designed for removable drives. This thing could get up into the petabyte range. It's not universally supported, but all modern operating systems do support exFAT. So if you want to save a file to a thumb drive, okay, for example, my wife had me save a file for some friends today on a USB drive. The USB was exFAT formatted. I don't know if they're using a Linux machine. I don't know if they've got a Mac OS wherever they're at. But with exFAT, I can guarantee with reasonable without reasonable doubt that whatever they put it on is going to work. exFAT, it works on all modern operating systems, okay? But FAT32 is still the universal file system, okay, used by everybody. Then we have NTFS. NTFS stands for New Technology File System. This was introduced back in Windows NT in 1993, and there's been many updates since then. It's been the file system that's been native for all of Microsoft's kind of business computers, the NT, the Windows 2000. When Windows XP came out, it kind of ended one branch of Windows, the whole 9X world. And Windows XP, and ever since then, the native file system has been NTFS. That's the native file system for all versions of Windows that consumers are going to use, at least, since Windows XP, although it existed before then, but that was for business environments, okay? And I'm not going to go into the history. It is fascinating, but it's already 8:30, and this is our second live stream, and if I drink much more coffee, the heart rate's going to go up. So that is a conversation for another day, okay? NTFS is proprietary to Windows. And what's cool about it is it introduced a whole lot of really cool features that weren't common or didn't exist really before then. It improved cluster sizing, compression, encryption, disk quotas, redundancy, and security. Now, some of these features work on all versions of Windows. Some don't work on others. So, for example, Windows 10 Home does not allow the encryption as far as the NTFS standard is concerned. So, cluster sizing. If you've ever tried to find a parking spot and you see an open parking spot and there's a motorcycle parked in there, well, there's a whole lot of space that motorcycle is not taking up in that parking spot. But that entire parking spot is now taken up by the motorcycle. Well, imagine for a moment if motorcycles had their own parking. It's a smaller spot. They're using the space better, but it's not taking up an entire spot that a car could take up. Well, this is cluster sizing. Information is stored in clusters on the hard drive. If a hard drive does not monitor the cluster size, it could really use up a lot of the hard drive for information that doesn't take up that entire cluster. Maybe a little bit of information in that cluster, but now the whole cluster is taken up. So by having better cluster sizing, we can store more on the hard drive than if we don't have the right cluster sizes. You can do default or you can set them on your own. As you can see, we can set our own cluster sizing. Compression. One of the cool things about NTFS is you can do what we call compression on the fly. Now, in the old days, for compression, you had to zip a file. And if you wanted to use anything on the file, you had to unzip it. Well, with compression, you can have a folder where you put things in, you can access those things in real time on the fly, and things don't have to be compressed and uncompressed. It's all handled again on the fly, which is pretty cool. Compression basically is saving space. Okay, it makes a file as small as possible so you can save space on it. Then we have encryption. Encryption is basically where if somebody unauthorized sees something, it's a bunch of gobbledygook and PowerPoint just crashed. But that's okay, because let me actually create some folders for you. Let me create a folder. Yeah, let me do this while I'm waiting for Windows for PowerPoint to come back online. I told you I was going to have at least one of them die on me. Let me see if I can find it real fast. Do. Oh, come on. Where are you at? Working with stars. There you go. All right. I'm restarting up PowerPoint, but while we're doing that, I'm going to show you the other thing I wanted to show you as far as what this actually looks like on a computer. Okay. So here I have an actual folder, okay, on my virtual machine. If I go to advanced, I can actually set it to compress. Let me click OK. Let me click OK. And I don't know if you can see it on your screen, but there are two arrows facing in. That is compression. I can put things in here and pull things out in real time. Nothing bad happens. Let me go back to properties again. And let me click on advanced. And let me switch it to encryption. Notice you can't have both at the same time. So I'm going to click this to encryption. This does not work on Windows 10 Home. You have to be Pro or better. So let me click OK. Let me click OK. And yep. This is now encrypted. Anything I put in here is now encrypted. And it does it on the fly. All right, let me pull out this again. There we go. All right, so that's encryption. And we use something called EFS. EFS is encrypting file system. This is what this uses. It's not really a file system the way we talked about file systems, but you do need to know that that encryption on the fly is EFS. All right, so we can see here, here's a little quick demonstration. I just did this for you in person. Take a little sip of coffee. My voice is getting a little rough here. All right. So again, know that the encryption that the NTFS offers is encrypted file system. That's EFS. We will talk about a better encryption system in security because that ain't it. Then we have disk quotas. Disk quotas allow an administrator to kind of limit the amount of space that somebody else can take up on the same computer. So you can turn on disk quotas through NTFS. And I'll let the graphic play for you, the animation play for you so you can see how it works. Right click, go to properties, and there is a tab for quota systems. Okay. Then we have redundancy. Redundancy is very helpful. What they've basically done is they've taken the master file table, okay, and they've taken NTFS keeps a backup copy in the middle of disk. So what happens here is that they've moved the master file table to the middle of the disk. With the thought that is that if the middle of the disk is destroyed, that entire hard drive is destroyed anyways. So it's less of a chance of it being damaged. Okay. Then we have security. Security is a huge thing with NTFS. In fact, we'll look at security later, where you can access things based off of your rights and permissions. So with Windows 9X, we really didn't have security. With NTFS, we can actually control access to files and folders on a drive. And when we get into security, there's a lot more about NTFS and security and permissions and all this other stuff that you'll be made aware of. And I think I've kind of beaten the dead horse on this one. Okay. Actually, no, I'll take that back. So FAT1632 supported by all operating systems. exFAT supported by all current versions of operating systems. NTFS is Windows supported. Linux can read and write to NTFS depending on the kernel. And Mac OS can read NTFS, but it can't save to it. All right, what else we got? You can see what type of NTFS you have. If you open up your command prompt and type in a simple command, this is it right there. We're not going to do that right here, but you can see what version of NTFS you're running. That's not in the exam. Then we have the Apple world. Then we have Mac OS. Mac OS has their own file system. The original, or the older one, was HFS, which stands for a hierarchical file system. It's proprietary to Apple, Mac OS. They improved it. Then they created HFS Plus. And now they use APFS, which is Apple File System. Now, let me give you this warning. You might be asked on the exam, which of these is used by Mac OS? And maybe you're like, okay, I know APFS is the answer. APFS is what it's currently using. But APFS isn't an option. Remember when the test was written. Sometimes you have to think of the year when the test was written to find the right answer. So if the test asks you, for example, what file system does Mac OS use, and APFS isn't on there, but HFS is, there's your answer choice, okay? Then we have Linux. Linux has extension. Again, this is most distros of Linux. Linux is Linux, so you might have something completely different, but this is the default file system in most distros of Linux. And ext4, extension 4, supports volumes of up to 1 exabyte. That's a lot of data. And it's backwards compatible with extension 3 and extension 2. The Linux file system can read and write to pretty much everything, which is pretty cool because it's Linux. All right, maintenance and care of storage devices. So we have something called error checking. Sometimes part of the hard drive goes bad, okay? Error checking is going to search the drive for bad clusters, bad areas where we store information. In the Windows world, you might hear terms called scan disk or check disk and error checking. Scan disk is the older error checking program that can be launched in the graphic user interface, the GUI. Check disk is the error checking program we launched in the command line. And I covered check disk in more detail, if I remember correctly, in our command line live stream. And then error checking is the general checking program in the graphic user interface. So here we see error checking, okay? This is the current iteration of error checking in Windows. It's fairly simple to do. You right click on a drive, go to Properties, Tools, Error Checking, and click Check. On Mac OS and Linux, you have different ways to do it. Linux, of course, has what Linux has. You can run a tool fsck. On Mac OS, and I think we talked about this in another live stream, you have First Aid. This is a utility found in Disk Utility. This is check disk. This is run in your command line. I think we covered this in more detail in our command line live stream. If you just type in check disk, it shows the status of the disk. If you want true power in your check disk, you add these different switches. You can do F, which will fix errors on the disk. R will locate the bad sectors and try to recover information, while X will force the dismount of the volume if you need it. You might actually need to reboot the computer for check disk to actually work on your C drive. Then we have something called SMART. SMART stands for Self-Monitoring Analysis and Reporting Technology. We talked about that when we talked about ATA standards. It was designed by IBM, and it's supposed to tell you if your storage devices are failing. Windows has a built-in tool to check the SMART status. It has been my experience, however, personally, that by the time SMART gets involved, it's already too late. So you can check SMART by launching command line. You can type in those commands that you see there on the screen to get more information about your drive. Again, it's been my personal experience that by the time this kicks in, yeah, you already had better make backups of your data, okay? For those of you still hanging with us, thank you very much. I know it's 8:37. It's been a long couple of hours. I know my voice is changing a little bit because of the talking. So thank you very much for hanging. If you're watching this and it's already been recorded, again, thank you for watching it. Go back and rewatch some of the stuff if you need to. It's all there for you. Okay. So let's talk about fragmentation. So fragmentation, not all parts of the file are saved together. So for example, let's say that I'm writing a letter to my mom. Okay. I might start the letter today. Today is Wednesday. And I might write something. Or actually, you know what? Let me instead of talking about writing a letter to my dead mom, let me talk. Ooh, the humor gets dark the later it gets in the evening. Let's say that I'm working on curriculum development. I'm writing a PowerPoint on troubleshooting operating systems. That's a little bit better of an option. So I'm writing my curriculum and I worked on it today. Okay. And let's say tomorrow, I might do something else. I might work on something else that's different. Then Friday, I pick up the PowerPoint and the thing again, and I write more curriculum. Well, the data isn't saved right next to each other, okay? That PowerPoint, although saved as a PowerPoint, might have pieces over here on the drive and here on the drive and here on the drive. They're not saved right next to each other. This is called fragmentation. This used to be a big problem back in the early days of computing because, remember, those hard disk drives got to move those read-write heads. And so it might have to go here and here and here and here to get that information. And it could really slow down your computer. And I remember back in the DOS days and the Windows 3X days that you would run defrag quite frequently, at least once a week. Otherwise, you would notice your computer getting very sluggish, and just take forever to get stuff to load. Now, in the modern versions of computer and modern versions of Windows, it's gotten a lot better as far as the fragmentation goes. So this is an old school picture. This is what we used to look at. It was actually very zen, which is kind of neat. You would typically set it to defrag and then go to bed for the night. Fragmentation, how to fix it. So modern day operating systems, like I said, do a great job at limiting fragmentation. So it really isn't as necessary as it used to be. Plus, a lot of these are automatically done for you without you knowing about it. In Windows, you run optimized drive to do your defrag. With solid state drives, because there are no moving parts, it's not as important. Instead, what we have there is something called retrim. It lets the solid state drive know which sector on the drives are not being used. We have disk cleanup. Disk cleanup removes storage areas that you don't need. This can kind of fill up over time, over use. And so disk cleanup is a quick way to kind of scan your hard drive for files that you might need to reclaim some space to, get that storage space back. So things that you can look at, for example, temporary internet files that you don't need anymore, downloaded program files. You've already installed the program, get rid of the installation files. If you've got things stuck in your recycle bin that you want to get rid of. So this is what disk cleanup does. All right, so when hard drives go bad, so if you recall from earlier that before a new hard drive can be used, you got to go through these steps, right? You've got to go through all these different steps. Now, if you look at the graphic here, you obviously have to connect the drive, right? You have to physically connect the drive to the computer. We saw initialization of the drive. Then we partition the drive, then we format the drive, okay? The low-level format, again, should have been done at the factory. But we have to connect the drive. We have to initialize the drive, which you saw when we did the virtual machine. You have to partition it and you have to format it. So things can go bad at any one of these stages. So the first thing you're going to do is you're going to check the connections. Is it connected? Is the cable connected? Is the cable connected to the hard drive? Is it connected to the motherboard? Is the cable frayed? Does it work? Is the power working? Is the power connected? Is power coming out where it's supposed to come? So how to fix it? Well, you check your cables. If the cables are bad, replace them with a good cable. Also check your BIOS UEFI to make sure that it can see it. If your BIOS and UEFI cannot see your drive, Windows has no chance of seeing it. So if your BIOS UEFI does not see your drive, you've got most likely a hardware problem. Either the drive's bad, or the connections are bad, or the power supply going to it's bad, but you have a hardware issue. I'm assuming that it's not disabled in BIOS, but if BIOS doesn't see it, it's not a Windows thing, it's a hardware thing. Uh-oh, we're gonna crash. Oh, and there it goes.
I meant to do that.
Let me relaunch PowerPoint again. It's getting a little annoying, honestly, especially this time at night where we've got about 15 minutes left of the live feed and we are crashing. But we're almost done, folks. For those of you hanging with me, we're almost done with our presentation for the night. So we are really close. So just hang in there a little bit longer, okay? We're almost there. All right. So partitioning, did we partition it correctly? Was the hard drive partitioned? Did the user select the correct size? You know, maybe we're like, oh, we got a terabyte hard drive and it's only showing 20 terabyte or 20 gigs. Well, did you partition it correctly? Did you set aside the space correctly? Okay. Easy solution, just add to the partition or reformat the drive, assuming there's nothing on there that you don't want to lose. And we already showed you, I think, in great detail, disk management on how to partition. Also check to make sure it's formatted correctly. Remember, formatting is the last step. You saw firsthand in the virtual machine that the drive didn't even show up in my computer, right? This computer, until I had partitioned and formatted the drive. So if it's showing up in disk management, but not showing up in this PC, you got to make sure that you partitioned it and formatted it correctly. And like I said, I already showed you disk management quite a bit. If you missed it, just go back earlier in the video and watch it again, okay? New drives or drives that are known good, a full partition should be done. If any type of formatting is taking a very long time, like I said, it might be a bad drive. You can run diagnostics on it to see if it's still good. Now, always keep in mind that storage devices fail. It's never a matter of if, it's always a matter of when, okay? So all drives are going to fail. This fail could be instant death, or it can be a slow, prolonged process. Instant death, everything is working and now boom, it's all dead. The drive just stopped working. The drive can't be found. The operating system can't be found. It won't boot. Assuming that it's not a connection problem, the drive's just dead, okay? So hopefully you made a regular backup. Hopefully you got backups of all your data, because if it's dead like this, it's dead. Unless you want to send it to a clean room to get repaired, it's dead. So that's why it's important to make backups of your data. If you're using cloud storage anyways, like Dropbox or OneDrive or whatever, you're good, okay? A slow death, you start to hear noises, okay? For example, you could hear clicking, high-pitched squeals, grinding, rumbling. You not necessarily hear stuff, but here's the deal, right? If you have a car, any new sounds on a car always means money, right? If you get a new sound in your car, it means something's gone bad. You're going to spend money. Well, if your hard drive starts making noise and it wasn't making noise before, that's a bad sign. That means that drive is fixing to die. How fast it dies, who knows, but it's fixing to drop dead. You could get boot problems. You could get BSODs, the blue screen of death. You could have system crashes while you're trying to run error checking. And of course, you could have corrupt data. The best way to deal with dying hard drives is when they're healthy. Again, make backups. You really should be storing, my personal opinion, to some sort of software as a service on the cloud. For example, OneDrive or Dropbox, Google Drive. I'm not really a fan of Google Drive, but I use OneDrive. I use Dropbox. You have iCloud, right, for Apple. I think I just talked about that yesterday. I should know that one. But for me, like, I just bought a new laptop not long ago. all my data is on the cloud. I can literally spin from one computer to another computer and work on the same documents because they're all stored on Dropbox and not on my individual computer, which makes life a lot easier. You can do this with your phones too, by the way. Okay, so you can sync your phones with your online storage. If the drive dies, there might still be a way to save your data. You might be able to boot to, for example, a Linux distro on a thumb drive and try to save the data, or you might be able to pull the data off of the drive. Okay. Now I'm going to close PowerPoint. That's my choice. Let me show you one last time the QR code. This is for our Discord channel. You can join it, get help. We have a whole bunch of students who are also studying for their certification. So you're more than welcome to join us in working on your certification. Additionally, the tool that I used today was Oracle's VirtualBox. It's a free download. I would highly, highly, highly suggest that if you are studying for your A+ certification, that you get a copy of this, because there's things that you're going to want to configure in a virtual environment without the risk of messing up your normal computer. And also, I might add, if you're on a Mac computer, if you're on an Apple computer, you can also download VirtualBox and run a virtualization of a Windows computer. So if you're on a Mac computer, you don't have to go buy a PC in order to play around with Windows 10 or Windows 11. You can do that through Virtual Machine. And when it comes to Linux commands for Mac OS, Mac OS you have Terminal, but with Windows folks, you can install distros of Linux into the virtual machine and get hands-on experience with Mint or Ubuntu or whatever Linux distro you want. Let me pop up one more time our QR code for our Discord channel. Okay. And let's see, we are at 8:49, so we're still short of the 9:30 marks, but I've been talking for about an hour and 17 minutes. So with that, tomorrow, Thursday is going to be our last live stream during spring break, and I'll be talking about ITF Plus certification. I can't remember off the top of my head what we're covering. I think networking might be in there. It's a long lecture, but you're more than welcome to join us. I'm a teacher here out in Humble. This is me trying this out to try to help not just my students, but folks around the world. So I really would appreciate your feedback on how you like it, what can be improved, and is this doing you any good? Okay, so if this does do good, I might be doing a live feed or a live stream maybe once a week to help those of you out there to get that certification as you go through. Okay, but that's it from me. I have dinner waiting for me at 9 o'clock at night. So have fun studying out there. Again, thank you for joining me. I know it's been late. I wish you all the best. Join our Discord channel. Drop me a line. Let me know how you're doing. And also let me know if you get certified. So until later, goodbye for now, and good luck studying out there.